In this video, we'll be exploring the dynamics of a Soyuz upper stage rendezvousing with the International Space Station. The Soyuz rocket is currently the only way the U.S. space program can transport astronauts to the International Space Station with cooperation between the U.S. and Russian governments. This page displays the equations of motion for a spacecraft. It is important to note that there are both disturbance torques due to environmental effects as well as control torques to change the attitude of the spacecraft. The disturbance torques are displayed and include solar radiation pressure, aerodynamic torque, and gravity gradient torque. Below we have the equations of motion that we are familiar with from our lectures in Aero 320. These equations are nonlinear and must be solved by an iterative method. The inputs of the system include Euler angles, quaternions, and angular rates of the spacecraft. The outputs are Euler angle rates, quaternion rates, and angular acceleration. In this video, we see Soyuz rendezvousing with ISS. Soyuz aligns itself with the LVLH frame and the ISS body frame so that it is pointing nadir. It then approaches ISS on the R bar and docks with ISS. This video is sped up to view the whole rendezvous process in a timely manner. The spacecraft measures its orientation and angular motion relative to a fixed reference frame. Such a measurement can be made with a star tracker on board the spacecraft. It then transfers to a laser rangefinder as it switches to measuring its relative position to ISS. This slide displays the control diagram of the spacecraft system. This block diagram includes a PD controller as well as a block including the equations of motion. The state vector can then be plotted. This last slide graphs the equations of motion over a period of 50 seconds. When aligning itself with the LVLH frame, the Euler angles go to 0 or negative 2 pi. The angular rates go to 0 and the quaternions go to 0, 0, 0, 1. Depending on the gains of the PD controller, the dynamics will align slower or more quickly.